This is a summary of the most important issues of climate change and its entanglement with ecosystems and human justice. It will take about 15 minutes, but I hope it encourages you to read more details in the different slide presentations. Historical temperature records, analyzed by 5 independent scientific organizations, have unanimously shown significant warming since the beginning of the 19th century. Average global temperature has increased 1.5 degrees Celsius. Warming is relatively higher over the northern hemisphere at higher latitudes, and over the Arctic. In some of those regions the rise in average temperature reaches 4 degrees. Warming is larger over land than over sea. Very hot days are hotter and occur more frequently, while very cold days are less cold and less frequent. The top 10 warmest years fell between 1998 and present. Warming is detected in all seasons, but it is relatively more pronounced in winter and spring. However, there are regions that can temporarily be cooler than normal. Warming is taken up for more than 90% by oceans. Circulation in the oceans distribute the heat all over the world. Warming is now detectable at a depth of 2,000 meters. The main cause of global warming is human activity. Massive use of fossil fuels for energy production, industry, transportation, residential needs and technology caused enormous and ever-increasing emissions of the greenhouse gases, carbon dioxide, methane, nitrogen oxide, halocarbons, and ozone, and emissions of black carbon dust. Heat from solar radiation is absorbed by the Earth's surface and re-emitted as infrared. Greenhouse gases absorb this infrared and re-radiate part of it, a mechanism known as radiative forcing. Infrared is the warming radiation. Radiative forcing is amplified by water vapor. Solar heat is also absorbed by black carbon dust and re-emitted as infrared. Most warming comes from carbon dioxide, as it is the most important emitted greenhouse gas, both quantitatively and in terms of residence time in the atmosphere. Methane, ozone, and black carbon dust substantially contribute to warming. In addition, humans engaged in massive deforestation, which lowered the natural capacity of carbon dioxide removal by photosynthesis, leaving higher levels of carbon dioxide in the atmosphere. Humans also vastly expanded agriculture, resulting in increased methane production from digestive processes in cattle. Moreover, mining of coal-bed methane and shale gas deposits makes methane leak to the atmosphere. Direct measurements of greenhouse gases in the atmosphere over the last 50 years and reconstructions of greenhouse gas levels in the further past from proxies in sediments have shown a sudden and steep rise to a level 43% higher than prior to the industrial epoch. About half of the emitted carbon dioxide dissolves into the oceans, resulting in acidification and a decrease in carbonate ions, which are vital to shellfish and corals. Global warming causes melting of ice sheets, glaciers, and sea ice, particularly in the Arctic and the Antarctic Peninsula. Meltwater penetrates deep into the ice, speeding up melting and destabilizing the ice sheet, resulting in massive carving of ice shelves into the ocean. Arctic ice melts considerably faster than predicted by the IPCC in 2007. The surface covered by ice also decreased, which means less reflection of sunlight, leading to a vicious circle of more warming. In addition, black carbon dust settles with snow on the Arctic ice and the Himalaya. This leads to more absorption and less reflection of solar heat, again, accelerating melting. Runoff of meltwater from land ice to sea, and expansion of seawater by warming, increased the sea level about 30 centimeters over the last 150 years. In combination with storms and tides, local sea level can temporarily be markedly higher than global level and cause flooding. A warmer world leads to increased evaporation, resulting in droughts in lower latitude regions, and in more rain in tropical and higher latitude regions. Particularly, it is the intensity of rain and not the total rain time that has increased, facilitating flooding. Future climate can be projected by climate models. Climate models are mathematical representations of the physical processes that underlie the various elements of the climate system, such as radiation, diffusion and circulation in the atmosphere and ocean, ice melting, precipitation, and cloud formation. To find out whether a climate model is reliable, the model is applied on climate in the past, and the calculated climate change is compared with the observed change. If a model can correctly simulate the change from a starting point somewhere in the past, we can expect it to predict what might happen in the future. The models have proven to be quite accurate, as far as global averages are concerned. However, in terms of regional changes, the models often tend to over- or underestimate the change. Climate models have projected the continuation of fossil fuel consumption at the same increasing rate as today may increase average global temperature over land with 6 degrees Celsius at the end of the present century, compared to the pre-industrial temperature. Very hot days will be up to 11 degrees Celsius warmer than now, over the northern hemisphere at higher latitudes, and over the Arctic, and will occur more frequently all over the world. If average global temperature would rise above 10 degrees, which is possible in a business-as-usual scenario, the human body would no longer be capable to sufficiently cool in many subtropical and tropical areas. This would result in a catastrophic deterioration of life, and make large areas of the world practically uninhabitable. During the present century, droughts, storms, floods and wildfires are expected to increase in severity and frequency. Sea level will rise at least 50 centimeters and possibly 2 meters, which will inundate many cities located in coast areas. More typhoons and hurricanes like Haiyan, Sandy and Katrina will be disastrous. A point of great concern is the uncertainty about how methane, stored as hydrates in the ocean floors and in permafrost, will react to warming. If the hydrates destabilize, massive release of methane to the atmosphere could lead to a much faster warming than is now projected. Climate models have also determined that it takes several decades before the warming by a particular amount of carbon dioxide in the atmosphere is established, and that it then takes more than 1,000 years to fall to 20% of the initial level, even if greenhouse gas emissions would be set at zero. Once global warming has occurred, it remains warmer for millennia, because the heat is very slowly released from the deep oceans. Thus, climate change is irreversible on a human time scale. Consumption of coal and oil also produces many pollutants. Trees increasingly get sick and die. The number of human deaths during heat waves are increasing. Climate change, together with destruction of animal and plant habitats by human activities, leads to loss of biodiversity. If this continues, it may lead to a tipping point in the ecosystems, potentially resulting in mass extinction of many species, possibly including human, because humans heavily rely on the many services from nature. Climate change already displaces people from areas with high climate impact, creating climate refugees. This kind of migration is interconnected with other social and economic factors, such as poverty, water and food shortages and war. Most displacement is by shoreline erosion, coastal flooding, and desertification. Most of these refugees arrive today in slums. Climate refugees amounted to 25 million in the mid-90s, and are projected to be over 100 million in 2050. This may lead to major international conflicts and economic collapse. Moreover, climate change creates injustice, as those who contributed the least to greenhouse gas emissions will be most impacted. Regions with highest vulnerability are often the poorest, such as Ethiopia, Haiti, Bangladesh, the Philippines, regions in India, Cambodia, South Sudan, Sierra Leone, and Democratic Republic of Congo. Since climate change is irreversible once established, it must be abated immediately. The longer we wait, the higher the permanent impacts will be. There is still time to avoid a catastrophic evolution of climate change, if we all act now. Climate models have computed that carbon dioxide emissions have to be decreased by 70% before 2050, compared to emissions in 1990, in order to avoid warming at the end of this century above 2 degrees Celsius. Unfortunately, so far, international agreements are far insufficient to reach that goal. We can only hope that this will improve substantially at the next UN meeting in Paris, December 2015. The European Union plans a 40% reduction of emissions by 2030. That is an example for the rest of the world. The most effective approach to cut greenhouse gas emissions is by replacing fossil energy by renewable energy. It has been calculated by different groups that these systems can fully empower the world's energy needs, even if our consumption will further increase. Emissions can further be lowered by reducing energy use and improving energy conservation and efficiency. Also by reducing, reusing, recovering, and recycling materials, and by reforestation. Emissions of methane can be considerably reduced by decreasing cattle breeding and methane leaking during mining. The estimated cost for emission cuts would be $1 to $3,000 billion by 2030. This is less than what has been spent for the war in Iraq by the US only. Equally important are efforts to adapt to a warmer world, increase resilience, and decrease vulnerability to the negative impacts of climate change. The IPCC, UNFCCC and the World Bank have estimated the cost for adaptation to climate impacts between $50 and $200 billion per year. This is a very small fraction of the gross world product, which is more than $70,000 billion per year. The most direct approach to avoid dangerous climate change is by developing geoengineering technologies that remove carbon dioxide from the atmosphere or reflect solar radiation. Unfortunately, these methods are far from being proven safe and effective at a planetary scale. In conclusion, it's imperative that we start fighting climate change, not tomorrow but today. We are not only responsible for what happens here and now, but also, and even more so, for the world we leave behind for future generations. Not only policymakers, but also the citizens must act now. Think of the words of José Saramago, recipient of the 1998 Nobel Prize in Literature, that citizens have an obligation to intervene and become involved. Citizens can incite governments by voting for a political party that gives priority to environmental protection and social justice. Take your responsibility. Learn about climate change yourself, spread your concern to people around you, and do something yourself to reduce your carbon footprint. By doing so, people will follow your example. Realize that your effort will help to preserve the earth for your children and grandchildren. Modern civilization consumes the earth's resources, at intensities far above what is needed to fulfill basic needs for existence and prosperity. This is an astonishing paradox, as all cultures originally developed intuitive understanding of limitation, the frailty of existence, and the sacredness of natural environments. In search of prosperity, modern civilization has forgotten what intuition had learned, helped to foster its renaissance.